Right, so for today and tomorrow, we're going to take a look at what's called scatter plots. Okay, most of what we do today is going to be by hand. Tomorrow, we'll try to do a little bit more with technology. Okay, so a scatter plot, and that's what you want to fill in what's bold. A scatter plot is used to show if there's a relationship or a connection between two pieces of data. Now, if you just wanted to show a relationship, say, between how many minutes you study and the grade you get on a test, and you gave me a chart with 1,300 rows in it for every student in the school, and you put how many minutes they studied and the grade they got on the test, and I'm trying to look through 10 pages of all these numbers, it's not going to be very easy for me to see if there's a connection. But you draw me a picture, and then it's going to be a lot easier. So that's what we're really doing. Taking data, turning it into like a picture. So what you have to graph is coordinates. The x and the y represent something. In the example I just gave you, maybe x is how many minutes you studied, and y is the grade on a test. And you'll have a bunch of ordered pairs. Maybe you'll have like 10 or 15 of them, and you're going to graph them, just like you did on the warm-up. And then once you graph them, okay, on that second line, you want to put scatter plots are used to show trends or patterns in data. And there's different kinds of patterns. We'll talk about some names. Sometimes a pattern is strong, sometimes it's weak. Like you can say, oh yeah, there's a definite connection. Or sometimes you might be like, well, it looks like there's a connection some of the time, but not all of the time. So not only are we going to look at, is there a pattern, yes or no, how strong is the pattern? There's a way to calculate a number. Basically, it's a decimal from 0 to 1. 0 meaning very, very weak. 1 meaning as strong of a connection as possible. Okay. If there's time tomorrow, I'll show you that on the calculator. So if you get a number, like the calculator can do it for you, and it says, all right, the pattern is a 0.9. That's a really strong pattern. 1 would be perfect, right? If the calculator gave us a pattern and the number was like a 0.2, yeah, that's closer to 0. That means there's not much of a pattern. You're probably looking at data that looks like this. Just kind of random, right? There's not really any pattern. Over here, this pattern might be like a 0.7 or a 0.8. It's not perfect, but there's definitely a pattern there, okay? All right, so let's look at this. Here's an example of a scatter plot. So anytime you draw a scatter plot, a few things you got to do. And I think you guys already have this on your sheet. Actually, you got the next example, so you can just look at this. First of all, when you look at that, what do you notice about it? Anyone tell me anything you notice like about the scatter plot? Yeah?
The dots are kind of close together.
Okay, so to me it looks like there's a pattern there, right? It might be, if I were to try to just do my best to put a line in there, that's not perfect, but maybe kind of like that. Now, what is this a picture of? What is this describing? It's describing what? How do you know that? There you go, there's a title, right? That's important. Anytime you make a scatter plot, it's got to have a title, all right? Now, what about smoothies? Like how heavy they are, how much they cost, like, yeah?
I like calories and sugar.
How do you know that? There's labels on the axes, right? One axis is labeled in grams of sugar. The other axis is labeled in calories. So what this is showing us is a graph of how many grams of sugar you put in a smoothie and how many calories it has. Does it look like there's a connection between how much sugar is in a smoothie and how many calories the smoothie has? What does it look like? It's just the dots are random. There's no connection at all. What do you think, Nicole? Yeah. And this, I think we're going to get into looking at this in example 1. So I'm not going to get into too much more, but yeah, it looks like there is a connection. All right. We'll say what it is in a minute. All right, so let's look at that. So it says the scatter plot shows the amount where X is grams of sugar and Y is the number of calories in 10 smoothies. How do you know there's 10 smoothies? Where's that 10 coming from? How many dots there are, right? Showing the data for 10 dots. So if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. All right? 10's a pretty good number to have. Like, if you were looking for a pattern, could you tell if there was a pattern if there was only one dot there? No, you really got to have a bunch of them, right, to see a pattern. So the first question says, how many calories are in the smoothie that has 56 grams of sugar? Okay. How do I do that? How do I figure that out? How many calories are in the smoothie that has 56 grams of sugar? How do I use that picture to figure that out? How about Alex?
You find the dot that's on 56 grams.
All right, so we're going to find the dot that's on 56 grams. Let me make it, I know you guys got it. Let me make it bigger. So 56 grams in between 54 and 58. All right, so I'm going to make the dot a different color. All right, I found it. So there's the dot that's between 54 and 58. Now what?
And look at how many calories there are.
Look at how many calories. So which way, once I'm at that dot, which way do I go? Which way do I move to get to the calories? Yeah. So just go over to the left, just like that. So if you've got 56 grams of sugar, which is right about there, Ryan, how many calories is it?
270.
270. Yeah, good. That's it. So looking at, sometimes you're going to be given a scatter plot, and you just have to figure out some things about it. I think there are some where you have to make, yeah, you're definitely going to make your own on a couple of them, right, Mr. Roy?
Yeah.
Yeah, you've got to graph points by hand. All right, the next one. How many grams of sugar are in the smoothie that contains 320 calories? This is a little different. How do I do this one? Yeah?
It's just backwards.
Yeah, it's like you're doing it backwards, right? So the first thing you're going to do is find the smoothie that has 320 calories. All right. So you know what? Let me do it in red. All right. There's the smoothie that contains 320 calories. Now what do, Yusef?
So down.
Go down. And look where you end up. How many calories does that one have?
70.
Yep. 70.
70 grams.
Grams, yeah. 70 grams of sugar. Yep. 320 calories, 70 grams. All right, so now part C. It says, what tends to happen to the number of calories as the number of grams of sugar increases? So here's where you're actually describing the pattern. All right, so when we describe it, write a nice, full sentence. Don't just write one word like down or up. Just kind of write what's happening. So what happens to the number of calories as the number of grams of sugar increases? So as the number of grams of sugar, what do they want to know? Increases? Yeah, increases. Okay, what's happening? As the number of grams of sugar increases, what's the pattern? The number of calories, perfect. The number of calories goes up. Yep, what were you going to say?
I was going to say that the number of calories goes up by 10.
Well, we don't know exactly the amount, but as long as you describe the general pattern, you don't have to give a specific number. Once we get into drawing a line and using the calculator, we can do that more, but yep, same idea. You just have to say it goes up.
Ellie, that's kind of like going up by 10. That's just the way they chose to label the numbers on that side. That was the best. Sometimes you have to choose to go. When we asked you guys to set one of these up, you can't always go by ones. Sometimes you have to go by 2s or 5 or 8, whatever. That's the best way to fit them down.
Yeah. So, yes, thank you. I didn't know exactly what you were thinking at first. So the numbers that these go up by, that really is not what they're looking for. What they're looking for is, look right there. Look at the dots and what's happening.
And like those at the bottom of each axis, like the X and the Y, is like that little squiggly. That just means they skipped a whole bunch of numbers. Oh wait, so now you don't have to write like you don't have to number by 1 every time. And as long as you put that little squiggly thing, that means you skipped a whole bunch of numbers because that was the best way to fit your data.
Because see how they started at 240, then 250, 260, 270? Like Ali said, they're going up by 10, but they didn't start like 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, because there's no data for all those, all right?
There's no data in that range.
So you can use this, like Mr. Roy just said, use this symbol. It just means you skipped a bunch of points. Okay. Or I drew it the other way. Whatever, that's fine. Okay, so that's what they're looking for. As the number of grams of sugar increases, the number of calories goes up. That's it. Questions on that? All right. So we said that a scatter plot is used when you're looking for a pattern, when you're looking for a trend. Well, there's a word that we use to describe that. It's called a correlation. Remember that number that I was telling you guys earlier that the calculator can give you? Like it'll give you a 1 if it's a really, really strong pattern. It'll give you a 0 if it's a really weak pattern. I didn't tell you the name of that number, but the name of it, it's called a correlation coefficient. It tells you how strong of a pattern you have.
Guys, we're gonna talk about like when we're gonna use the word correlation in a minute, so don't worry about too much about writing down that definition.
All right, so a correlation is when there's a pattern in a set of data. Different kinds of correlations, right? And that's what we're going to look at right now.
So we're still on the front side of your notes, guys. It's on the bottom.
All right, let's look at the first one. The first one, okay?
Everybody know where we're at? You good?
It says, as x goes up, y goes up. That's kind of like what happened in the smoothies, right? As something went up, something else went up. So I think it was as sugar increased, calories increased. You just have to change x and y to whatever the two things are in your problem. Money, sugar, calories, whatever it is. If I wanted to put a line through those points by hand, I would say that one's pretty good.
And when you think about correlation, think about slope. Think about what we did with slope, the slope of a line.
All right. So now, as Mr. Roy just said, what kind of slope would this line have? Okay, I'm not even going to put the line in there yet. But if you look at all those points, think about a line going through them, what kind of slope would it be?
Up to the right.
Positive. Yep. So this is called a positive correlation.
Just like the slope of the line, it's the same exact thing. The only thing is we won't have like 0 or undefined. We're only gonna have positive and negative, and there's one more, I guess, type as well.
Okay, so positive correlation means as something goes up, something else goes up. So if you can have a positive correlation, what do you think the next one's going to be? A negative, right? That's a negative correlation.
Just like a negative slope, it goes down to the right.
So negative correlation. So if I wanted to put a line in there the best I could by hand, I don't know, maybe about like that. Just try to kind of put the line in the middle. But that's a negative correlation. What about there? So, well, actually, I didn't read this part, but as x goes up, y goes down. Okay? That's what happens in a negative correlation. As you go further and further to the right, as x keeps getting bigger, y is getting smaller. Right? So an example of that might be, pretend x is how much money you spend, and y is how much money you have left in your wallet. So the more and more money you spend, the less and less money you have in your wallet. So as your spending goes up, the amount of money you have goes down. Right? It'd be nice is that if you spent money, you had more money. It doesn't work that way.
I know what the next one is.
The next one? Yeah, what's the next one?
No solution.
Well, what word have we used in all of them so far?
No correlation.
No correlation, yeah.
They're kind of all over the place. There's no pattern.
So that means, is like Mr. Roy just said, there really is no pattern. You look at it, it's not very obvious that anything is happening. So we give you guys a problem on a test. If there's a correlation, it's going to be pretty obvious that there's a correlation. It's not going to be like, well, maybe there is, maybe there isn't. It'll be pretty obvious. And that's what Mr. Roy had said. You can think of correlations, like if you put a line in there, positive correlation has like a positive slope. A negative correlation, negative slope. Now, when I drew this line, when I did this, did I do any math to do that? No, I just kind of guessed, just took a guess at what I thought it would be. And I could find the slope of that line. We've done that before, where you take a point, take another point, and find the slope between the two. And that's what we're going to kind of do. But remember, I didn't do any math to get that line. It was just a guess, okay? Just a guess. Tomorrow, the calculator is going to put in the line for us, and that's not a guess. It's like the most perfect line you can have. I think it's tomorrow, I'm not sure. So Mr. Roy is going to go through example 2, and we're going to figure out whether the data has positive, negative, or no correlation.
All right. So guys, like the first, on the test, we will ask you questions as basic as this. I think the first 3 questions are going to ask whether it's positive, negative, or no correlation, just based on looking at the picture. And I think this week's test is only 12 questions. That's 3 of them right there. So that's like a quarter of the test is being able to identify if it's positive correlation, negative, or no correlation. So we look at this one, right? What do people think? Ryan, what do you think? Positive, negative, or no correlation?
No.
No correlation, people agree?
Yeah.
I agree too. Like we said, no correlation means it's kind of all over the place. All right? This is going to be on the back side of your notes, guys, on the top. All right? So this one, I would agree with Ryan. It's going to be no correlation. Again, we haven't get into we're going to talk about like a line of fit. We haven't get into that yet. All right? All we're asking you to do with these ones is just identify positive correlation, negative correlation, or no correlation at all. So this is talking about age and vehicle zone. Again, no correlation. Some of you guys already have the pictures. I'm sure some of you guys already figured it out. This next one. Jake, what do you think? Positive, negative, or no correlation? Negative. Negative, right? Because it goes down to the right. So this is going to be a negative correlation. It's going to be a negative correlation. Right? The lower the temperature, the more coats are going to be sold per day. All right? Last one. So now we're going up to the right. So Matt, what do you think that is?
Positive.
Positive correlation. Again, we're not asking you to do anything more than that. Just look at the pattern and identify what it is. That's going to be a positive correlation. All right? Again, it's just looking at the picture, identifying what it is. Nothing more than that. Right? And like Mr. Hager showed you, like we'll ask you a question like that, but there's a couple questions included in it. You know what I mean? Based on one scatter plot, we're going to ask you to say, okay, if it's 62, then how many calories? Okay, 290. It's just being able to read the scatter plot. All right. Did I miss anything else? All right. Next, example 3. We haven't done this yet. So now it's saying make a scatter plot of the data and tell whether the data shows a positive, a negative, or no correlation. So now we have to be able to make our scatter plot. We have to be able to label it. we have to be able to know where we're gonna put our points. It's not like all set up for us like the ones we did before this. We actually have to plot it. All right? So, what am I gonna label? What am I gonna label my x-axis? Someone tell me by raising their hand. What am I gonna label my x-axis? Yusuf?
Number 1, 2, 3, 4.
Okay, you wanna? Yeah, well, I agree with you, Yusuf. We're not gonna skip any numbers. We're gonna go. We're gonna do. Say again.
I know what you mean. I want to be like years.
Yeah.
Oh,
So it would be age of cars, right? So we gotta make sure we label. So 1, 2, 3, 4, 5, 6, 7, 8. They all fit, right? And that's gonna be like Yusuf. You said age of cars and years.
yeah.
So age of cars. That'll be years. That'll be age of cars in years. Now, this is where it gets a little bit tricky. Look at my data for this is talking about cost. All right, in thousands. So it'll be 20. A car that's like 1 year old obviously would be worth more money than a car that's, unless you're talking about a car that's from like the 1930s, something like that. But a 2006 car is not going to be worth as much money as it was in 2006. All right. But with this data, I can't label it the same way. I can't label it 1 through 8, or I can't go by ones. All right. I'm probably going to have to use that little squiggly thing to skip some numbers. What would be the best way? What would be the best way to number my y-axis? Savannah? Go by threes? Let's see. I just kind of plan it out first. 3, this will be 3, 6, 9, 12, 15, 18, 21, 24. So I kind of plan it out first before I write all my numbers, so I don't have to erase everything. 3s will work perfectly. It'll cover every single line. So 3, 6, 9, 12, 15, 18, 21, 24. Because guys, sometimes on MCAS, almost every year, next year when we take MCAS, almost every year they ask an open response question on a scatter plot. They almost always ask a scatter plot question. Now, a lot of times they'll say, you won't really have to set it up yourself. They'll say copy the graph exactly how it is in your answer booklet. So you don't have to go through as much of trying to plan it out. But we may ask you a question on Friday for the test where you're going to have to actually set up a scatter plot. And what am I going to label my y-axis? What am I going to label it? Yeah, this is going to be value in thousands of dollars. 24,000, 15,000. This will be value in thousands. All right. Now, I've done that part. I'm going to scroll back up a little bit. You can kind of see both. All right. So now I'm going to put my dots. All right. I'm going to do a dot at 1, and I'm going to go up to 24. Right? Because the way we numbered it, it worked out perfect. All right? I have a 1, I have a 24. It's not always going to work out that way. Bless you. Now, a car that's 2 years old is going to be $21,000. A car that's 3 is 19, but I don't have the number 19 labeled on my y-axis. Where's 19 going to go?
Why above 18?
Yeah, just a smidgen, like a smidgen above 18. Because if I put a dot right in the middle, between my 18 line and my 21 line, if I put a dot right in the middle, what number would that be? Yeah? 20, right? So I want to go kind of like a quarter of the way up. I want to be right about here. I don't want to be right in between, like Matt said, because that would be 20. I'm going to go to 4. What number am I going to look for on my y-axis? For that 4, what am I looking for on my y? 18? I have 18. I'm going to put a dot right on it. My next one, I'm going to be at 5. It's going to be 15, like Gigi just said. Good. I'm going to be 6. I'm going to be 12. I'm going to be 7, I'm going to be 8, but like we said, we don't have an 8, so we're going to be just below 9. And then I'm going to have 8, I'm going to be at 7, just above 6.
So like each year is more, like each year it goes down less.
Exactly. Like
So it gets older.
like Ellie just said, the older the car is, all right, the less value it's going to have. All right? That's why used cars are cheaper than newer cars. All right? Joe.
Is it 515?
Was 5.50? Did I screw up? I did. Thanks, Joe. 5.50. All right. So we did we set up our scatter plot. We put all our dots on it. We graphed all our data. Now it's asking us what type of correlation is that. Yusuf? Negative, right? It's going down. And like Ellie just said, she's like, well, Mr. When I look at it, the older the car is, the lesser value it has. This is going to be a negative correlation. Now, we're going to talk about in a little bit here, we're going to talk about a line of fit. That's what we're going to kind of guesstimate and draw a line. And then that's going to help us to estimate. We could say, okay, if a car is like 4 years old, how much is it going to be worth? We'll draw that line, we'll draw that estimate. Like Mr. Hager said, tomorrow, when we do it on because GG's line of fit could be completely different from, not super different, but they might be a little bit different, right? The numbers, the way it looks. Everybody's line of fit is going to be a little bit different. It's not going to be exact, it's going to be an estimate.
Please excuse this interruption. Attention all freshman teachers, please make sure freshman guidance sheets have been turned into guidance.
Perfect.
Again, all freshman guidance sheets should be returned to guidance at this time.
All right, so there's my,
Thank you.
so again, we just took it one step further. We had the graph, right? It gave us the data. We had to set up the scatter plot. That's all. All right? Next. Now we're going to talk about, all right? Now, like we just talked about, when data shows a positive or negative correlation, you can model the trend of the data using a line of fit. All right? So you guys don't really have to worry about the definition too much. All right? But we're gonna write down the steps right now. All right? A line of fit is a line drawn on a scatter plot that is close to most of the data points. So we're gonna talk about how to do that right now. All right? We're talking about a line of fit today. A line of fit is what you guys draw. Like I said, they're gonna vary a little bit. No one's line of fit is gonna be exact. All right? Tomorrow, when we do a line of best fit with the calculator, everybody's will be exact because we're doing it with the calculator. But a line of fit is a little bit, there's going to be a little bit of wiggle room there, okay? So, first step, we already did it. We did something like that in the last example. We're going to make a scatter plot of the data, right? It's going to give us all the coordinates. We're going to label our x-axis, we're going to label our y-axis, see the best way to number each line like we just did for the last one. So we're on the back side of our notes right now, more down towards the bottom. We have all the steps, you just have to write out what each thing is, right? So step one, like we just did in the last example, we're going to make a scatter plot of the data. All right? It'll give us the data, we plug it in. Number two, we're going to look at where all our dots are, where all our coordinate points are, and we're going to decide whether the data can be modeled by a line. All right? So we're going to look at, do we have a positive correlation, negative correlation? Remember, this line of fit is only going to work if we have a positive or negative correlation. It'll never work for no correlation. All right? That one we just did, it would work. We said it was negative, so we would be able to do a line of fit for that. If it has no correlation, we can't. Step three, draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it. So you want to, when you draw your line, you don't want if it's a positive correlation, you you don't want all the dots below the line. You don't want all the dots above the line. You kind of want an equal amount on both the top and the bottom. All right? Like I said, no one's line of fit is going to be exactly the same. It's not going to be, they're going to be relatively close, but they're not all going to be the same. There's going to be a little bit of width, there's going to be a little bit of difference with how some people's look. And because we're going to ask you to identify a slope when we do this. Your slope, like Savannah's slope, might be a little bit different than David's slope, but they're going to be somewhat within a couple decimals of each other. All right? So we'll pick our line, we'll draw our line, make sure we equal amount above and below. 4. It's the last step, right? Yeah. All right, so write an equation using 2 points on the line. The points do not have to represent actual data pairs, but they must lie on the line of fit. That means the data points that you put on there, you don't have to pick to figure out your slope. You don't have to pick those, like 2 of those points. As long as there are 2 points that lie on the graph, or on your line, I should say. And you're probably thinking, Mr. Royal, what the heck does that mean? I have no idea. Right? When we do one, it'll make sense. I say when you do it, you want to make sure your line goes through like a nice, like I call it like a nice bullseye. Right? You have like the little coordinate lines on your graph. You want to make sure that your line goes through like 2, I call them like nice points. You want to go through like 2 nice points. And that way you can figure out your slope. All right? So let's understand it. Like I said, this step 4 will make sense when we actually do one. Or when we get some data to graph. All right? Anybody need a little bit more time to copy this down?
I do.
That's fine. So like I'm thinking probably on Friday, guys, we're gonna make you do, because we spent so much time, we're gonna make you actually do a scatter plot. We're gonna give you the data. You're gonna have to make sure you label the points, make sure you number it correctly, make sure you do all that stuff. And then we'll have some questions based on that. All right? Let me do. There we go. All right. So example for the last example. A table shows the weekly sales of a DVD in the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. All right? Interpret the slope and y-intercept of the line of fit. So that at the end, interpret the slope and y-intercept of the line of fit. We haven't done that yet. We have to based on the line of fit that we draw, we have to put it in slope intercept form. Y equals mx plus b. That's what that means. So put in y equals mx plus b. So with this one, a little bit different because we're giving you the graph now. The graph's all set up. It's all numbered. It's all labeled. All you have to do is put in the points. The one we did before this, obviously, we had to set it up, right? So we're just going to figure out our numbers now, right? We'll look at 1 on the x-axis, 19. We're going to be right in between. It's going by 2s, so we're going to be right in between 18 and 20. We'll go 2. We'll go 15, right in between 16 and 14. 3 is 13, right in between 12 and 14. That one, we got 4 and 11. We got 5 and 10. We got 6 and 8. 7 and 7. Going across that, what is this like? And then 8 and 5. Good, right? Okay. So, if we go back to our steps, right? We did step 1. All right, make a scatter plot of the data. We did that. All right, plugged in all our points. All right? Now, decide whether the data can be modeled by a line. Bethany, does that have a correlation? Does that have a little pattern, do you think? Yeah, it does, right? Is it going to be positive or negative? negative. It's going to be a negative correlation, right? So yes, we agree. There's correlation there. All right, it's negative. So now we can draw our line of fit. Step 3, draw a line that appears to fit the data closely. All right, as many points above and below it. Now guys, understand here. It's not, don't worry. Some people get so paranoid, like, I think I'm doing it wrong. I want you to understand that your people's lines are going to be a little bit different. No two lines are going to be exact. The way that Jacob draws his to compare to how Mary draws hers. They might be a little bit different. They might be different when I draw mine. All right? So let me, So I kind of got a line set up there. So I'm just going to kind of play with it a little bit and get it to where I want it. What do people think? You think we got with that? Do we think we have an equal amount above? I mean, you're not always going to be like, you're not always going to like be able to count and say, okay, I got 4 above. That means I have to have 4 below. But if you have like 7 above it and 1 below it, then that's not a good line of fit. All right? You want it to be relatively an equal amount. If there's like 5 on the top, 4 on the bottom, that's okay. 5 on the top, as long as it's relatively close. But it's not always going to be an equal amount on the above it and below it. Now here, it just so works out that my line did go through 2 of the points that I drew, or that I put in there. These 2. It's not always going to work out that way. All right? Because I could pick, when I do this, when I look at my line, I'm looking for coordinates, or I'm looking for points on the line. Like, I could even use this. I could even use this right here. I know you see how my line goes through, I call it like a bullseye. It goes through one of my coordinate grid, one of my coordinate lines. I could even use that if I wanted to. But in this case, I have 2 points on my graph, this one and this one, that I could use to figure out my slope. But anything that goes through nice like this, kind of circle it so you can see. Right here, I would say I would use that coordinate because it's on the line. It doesn't have to be one of the dots that I drew. As long as it goes through, like the bullseye perfectly, then you could use that as well. But for this case, I'm going to use this, and I'm going to use this. I'm going to use those 2 points to figure out my slope. All right? So I got to figure out what those 2 coordinates are. So the top one, right? What's that coordinate? I want to set it up as a coordinate. What would it be? What, comma, what? This top one. Let me go.
5 and 10.
All right. Scroll down a little bit. So, Chris, you said 5 and 10? 5 comma 10? 5 on the x. And 10 for my y. That's one coordinate. Understand when you're doing these guys. You can't always, like before we said we had slope, we could like count. Be careful doing that when we're doing scatter plots. Why can't we count? Why can't we like count the number of lines? Mary?
Because it doesn't always go by 1.
Exactly. This one's not going by 1s. It's going by 2s, and you got to be careful with that. So here, I would say best is figure out your 2 coordinates first. So like Chris said, 5, 10 for my top one. What about the bottom one?
6.
We got 6 for my x, 8 for my y. 6 comma 8. There's my other coordinate. Now, I want to figure out slope, right? I can't count, even though I'm given a picture, I can't count because it doesn't go by 1s. So what do I have to use? There's a specific formula I have to use. Anybody remember? Mary?
y2 minus y1 over x2 minus x1.
Exactly. And I don't care if it's the other way around. I don't care if it's y1 minus y2, x1 minus x2. As long as you're consistent, I don't mind. All right?
I don't mind either.
Mr. Hager doesn't mind either. He's a good guy. Joe, What would I label that 5? What would it be? What would my label be for that? So I can plug it into this. Y, careful. What comes first in the alphabet, X or Y? X1, this is going to be Y1. Then my bottom will obviously be X2, Y2. You don't have to label them, guys. I'm just showing you so you can see what the coordinates are. If you know how to plug it in, that's fine. I do it so I don't make a mistake. I'm going to draw my fraction bar. I'm going to put my 2 minus signs because they're part of the formula, right? On the top, what am I going to put? What are my 2 numbers? Y2 minus Y1. Gigi?
8 minus 10.
8 minus 10, you said?
Yeah.
Okay, good. On the bottom page, what are my bottom numbers going to be? Huh? We said 10 was a Y. We already used 10. We already used 8. 5 and 6, right? Which one's going first? Because you get x2 minus x1. Which one's going first? 6. 6 minus 5. Now, when I calculate this, what type, based on the picture we have here, what type of number should it come out as? Say again, Savannah? Negative, right? Because it's going down to the right. It's a negative correlation. That means that my slope has to be negative as well. So 8 minus 10 is what? Anybody know? Donovan? Negative 2. 6 minus 5? 1. Negative 2 over 1 is what? Negative 2, right? Anything over 1 is itself. There's my slope. M equals negative 2. So I'm putting y equals mx plus b form, right? I'm going to start with my y equals. I just figured out my m, right? My slope. What is it? Negative 2. What does that negative 2 have to have with it? X. Good, Nicole. I'm missing one thing. What am I missing? What do I need? Y-intercept, right? When I'm looking at a graph, right? What does it mean? What's the y-intercept mean if I'm looking at the picture? It's showing me what, Gigi? Where the line crosses the y-axis. All right? So if I'm looking at my graph here, right? Where does my line go through the y-axis? 20. Ms. Hager, for this, we want to call this like 19.8, or can we say 20?
You can go with 20.
20 is okay?
Yeah.
So guys, you can go to the number, even if you said, would you be okay with 19, Mr. Hager? Would that work too?
Yeah, 19's okay.
Yeah, something in that range. That's what I'm saying. It's not going to be perfect. And some people, I mean, your slope should come out pretty close to 2. All right? Your y-intercept, some people, when you do this on your own, some people might have 19, some people might have 20. That's okay. If it's a multiple choice question, we won't put numbers that are that close. We'll put like 20, 10, negative 10. We won't put them that close together. So we're going to say plus 20. So that is, here's your line of fit. Here's your line of fit in slope-intercept form. All right. Ms. Hager, is that what you're looking for there when you talk about, it says interpret the slope and y-intercept of the line of fit? Is that what you want, is to put it in slope-intercept form?
So when they ask you to interpret, like, in the context of the word problem.
Okay.
So kind of like, for every this is happening.
Okay.
So the slope, let's take a look. So that's negative 2. All right? So that would mean, and if you thought about it, rise over run, what's negative 2? Negative 2 over what? Over 1. All right? So we take a look. Let's just see what's happening. So that means for every week, right? Rise, think of it like this, over run. Which letter is the rise? Those are your rise.
So the x or the y?
The y. In the run? X's, all right? So what's happening is for every week that goes by, the sales in millions are going down 2, and that's in millions. So for every week that passes, the sales drop $2 million on average. Does that make sense? For every week that passes, sales drop $2 million. That's what it means when it says interpret the slope. Now, interpreting the y-intercept. If the y-intercept
$2
is...
million, Mr. Hager?
Yeah. And we said drop because it was negative. Right? Now, the y-intercept is at 20. What's the coordinate for the y-intercept? How would you write it? Yeah? 0, 20. So what, now they want to know, what does this mean? What's the 0 mean in this problem? 0 represents what? X, and X is labeled as weeks. So what does week 0 mean? Well, I don't know what you mean. It's what? It hasn't started. That's the beginning. So in the beginning, the sales were 20 million. That's what the sales started at. So when they ask you to interpret the y-intercept, you could basically say, in the beginning, the sales were 20 million. Or sales were 20 million to start. Okay, something like that. Yep, exactly. Sales started at 20 million. That's what the y-intercept means. So when they ask you to interpret it, you just put it in the context of the word problem.
Just explain it. What those things mean. All right? So like Mr. Hager said, it's just going to explain a little bit when we ask you to do that. So make sure you put it in slope intercept, then make sure you explain yourself. All right? So to interpret your slope for every week that passes, because it's rise over run, for every week that passes, all right, sales drop $2 million. And then, like we did, I think we looked at, might have been the last MCAS question we did, and it talked about like the package, there was like a graph, and I think like the cost of the package started at like $20 to ship it or something like that. We did one like that. All right? People okay with this? People still need it? Yes? Maybe? Let me do a double so you guys can see. All right, guys, I got a few practice problems for you to do because we got some time left today. I don't know if Mr. Hager talked about this before I got up here, but it is the first week of third quarter. All right, grades have closed. Congratulations, you guys are halfway through the school year, over halfway at this point. All right, as I look through, I came to see Mr. Hager, I think on this past Friday. I looked at some grades. Some people's grades for second quarter weren't so good. I think part of that is based on the amount of effort they put in during class time. The amount of time they pay attention while Mr. Hager and I are going over stuff. The amount of homework that they do. All right? I'll be after school this week on Thursday. If you're not doing well on tests and you want to stay with me on Thursdays, I can stay till 4 o'clock. Some people have stayed with me before this year. We can make sure your reference sheet's all set to go. Any last minute questions you have on the stuff we did during the week, anything you weren't sure about, we can get you all caught up to speed. You'll kind of be feeling confident, so for the next day you can take the test. But I can't make you stay. Mr. Hager can't make you stay. All right? You may think in middle school you kind of got pushed along. All right? That doesn't happen here, guys. I hate to bring it up, but it doesn't happen. Like summer school's a real thing. It happens here. Like if your grade's below a 60 for your final grade, then guess what? You don't go on, you have to go to summer. If you want to become a sophomore and you fail math, you have to go to summer school. Either you go to summer school and make up the credit, or you're a freshman again, and you have to re-explore. There's no guarantee you get into the shop that you have. So I just want you guys to keep that in mind. Right? We make this, I think Ms. Hager and I make this, we give you the most information. It's set up really, really well. You're not going to get this in any other Algebra 1A class. I guarantee you. Ask your friends. All right? Teachers make you do a lot more than what we do. We're giving you the basics. All right? We're making it as fair as possible for people to pass. You're just going to try. All right? We're only doing 3 days of sections this week. Well, actually, we're only doing 2 sections. We did 4-4 today. We'll do 4-5. We'll break it down into 2 parts. Again, it's all on scatter plots. Thursday, we're gonna do an MCAS question. The MCAS question will deal with scatter plots. All right, and then also we're gonna do a test review in class for the second half. All right, make sure you bring your Chromebooks on Thursday. All right, we're gonna do some online stuff with scatter plots. I know we haven't used the book at all, but the book is online. We're gonna have you guys do the review online. That way next year, because next year we take MCAS. MCAS is all online. It's all on the computer. So I just want you guys to get a little bit more familiar with that. We'll probably only do like stuff on the computer for like test review like twice a quarter. Right, so tomorrow, Thursday will be one time, and we'll do it another time before the beginning of April. All right? Test on Friday is not super long, guys. I looked at it. It's only like 12 questions. And the first 3 is asking you guys to identify what type of correlation it is. All right? Questions? No. Straight. What am I hitting here to stop this? Oh, you do. I'm going to screw it up.